we're going to hand back the papers from yesterday, and then you are going to talk to me about what questions you have. So let's see here. Ben's not here. Sam's not here. That one's not here. Maybe he is. Here it is.
Oh, that's
Anybody?
They might just not be here.
Natalie?
I'm pretty sure Philip was only taking physics. And I don't know what this is. Stats apparently not for a couple of days. Wait, Bronson. I cannot get it.
I put like random things.
Okay. All right. Who found something in homework on the review sheet? Anything? Who found something we need to get straightened out before Thursday? Bronson?
On 7.3 homework, number 3.
All right, 7.3 homework, number 3. You should have that back. See if you did it. Number 3. Okay, now what caught some of you on this is that you didn't pay attention to the sixth word of the sentence. Write the equation of the cubic polynomial. So what does a cubic polynomial look like? Ax cubed plus bx squared plus cx plus d. That's what a cubic polynomial looks like, right? So we're going to take each of those points, each of those given points is an x and a y. So negative 37, and I'm putting in negative 2, so that's going to be negative 8a plus 4b minus 2c plus d. If I put in negative 2 for all the x's, and then negative 11, now I'm putting in negative 1, so it'll be negative a plus b minus c plus d. And then I'm putting in 0, so that's just going to be d, because those are all plugging in zeros. And then positive 2. So 8a plus 4b plus 2c plus d. So there's your system of equations, Bronson. And then it says you can use a calculator. So, I mean, if I'm doing this, I'm going to put them in and use Gauss Jordan. I'm going to RREF it and come up with my answer. Now, if you wanted to, but right now you've got 4 equations, 4 unknowns. That's perfect. If you wanted to, you could actually, since you know what D is already, you could actually stick negative 5 in there and then have just a system of 3 equations, 3 unknowns if you wanted to. That would be, that's just, whatever, that's your switch. Okay? And then whatever A, B, C, and D turn out to be, then you're going to plug them right back in here, and that's going to be your polynomial. Got it? Yep. All right, who else found something that we need to review? Tyler?
17 on review. 17 on review.
All right, so it says use Gauss elimination, so I'm going to do this by hand. So 1, 1, negative 2, 2. 3, negative 1, 1, 1. Negative 2, negative 2, 4, and negative 2. Okay. So I know my first job is to get zeros here. So I'm going to go ahead and copy that top row. And then to make this a 0, I'll multiply by -3, carefully, and add, so I get 0, -4, 7, and -5 if I multiplied and added correctly.
This one?
Yeah.
Is it -4, not -3?
Oh, what? I copied something wrong here? Yeah, thank you. Luckily, that hasn't impacted me yet, but it sure would here in a second, so thank you. All right, now I'm gonna multiply the top row by 2. And add. Uh-oh. Yep, what does that mean? That means that I'm going to have what kind of a solution? A parametric solution, right? I'm not going to get, x is 2, y is 3, z is 4. I'm not going to get that. Now, I'm also not quite in, I haven't quite completed the directions, because if I'm to use Gaussian elimination, my matrix needs to be in echelon form, row echelon form. So I'm gonna have to divide everything by -4. And now my matrix is in row echelon form, and I am ready to write my answer. All right, who remembers how to do this? How do I get an answer out of this? David?
Don't you just have to do it in terms of z?
Yep, so that bottom row, ideally, the bottom row looks like this. I mean, that's what I want to happen. That says z is 6. Well, it doesn't say that. It says 0z is 0. So basically, z can be anything, and we identify that by just saying z is z. Z is whatever it is, whatever you want it to be. Okay, now, the next row up in my last matrix, the middle row, says y minus 7/4 z equals 5/4. So y equals 5/4 plus 7/4 z. And then the row up from that says x plus y minus 2z equals 2. I know y is that, so x plus 5/4 plus 7/4 z, that's my y, minus 2z equals 2. So x equals, all right, now let's see. What's 2 minus 5/4? 3/4. I subtract the 5/4 over there. And these two added together make -1/4, so plus 1/4 z. If I move it to the other side. So since I don't have a z value, my y and my x are going to be in terms of z. So whatever I pick for z. So then I can write my answer vertically. In matrix form. So if I did my arithmetic right, no guarantees on that. I have 3/4 plus 1/4 z, 5/4, 7/4 z, and 0 plus 1 z. And that happens a lot when you solve big systems of equations. You don't always get a unique solution. All right? Who else found something that we need to look at? Sarah?
Number 3 on the 7/4 homework.
7/4 homework. Number 3. This is, we did this before too, so let's see, let's get it factored. I can pull out a 3x, it looks like, so I have x squared minus x minus 2 over x squared minus 4, and that factors some more. And the reason that I factor, one of the reasons I factor, is so that I can see if anything cancels out, and a whole bunch of stuff cancels out. So I'm going to be left with just 3x plus 1 over x plus 2. But the fact that I have canceled out two things means I'm going to have a couple of holes, aren't I? And they're going to be where x is 0 and where x is 2, because those are the factors that I canceled out. So if I plug in 0, it looks like I get 3 halves. And if I plug in 2, it looks like I get 9 fourths. So I'm going to go ahead and plot those points right now. So 0, 3 halves is a whole, and 2, 9 fourths is a whole. Okay? Now, what else? Well, let's look at this guy right here. I have a vertical asymptote at -2, because that's where my denominator would be 0. I have a horizontal asymptote at y equals 3, because 3x over x. I'm not going to have a y-intercept because I have a hole there. So there's no y-intercept in this problem. We do not touch the y-axis. But I do have an x-intercept, and it is at -1. So if I connect the dots that I have, I get that. And then we got to remember that there's another piece up here. You have to have something on the left side of your asymptote, your vertical asymptote. So this is what we got on the right, and then this is what we have on the left. Okay. You ought to be good at those. We did those before. All right, what else we got? Robert?
U4B on the review.
4B on the review. Alright. Okay, we got 3 types of television sets, 3 types of vehicles, vans carry. Ooh, there's a lot going on here. All right, so how many types of each vehicle? So I'm gonna let, let's see, X is, what have I got, vans? So X is gonna be the number of vans, Y is gonna be the number of small trucks, and Z will be the number of large trucks. All right, how many, I need to have 115 portables. Okay, so 115 portables have to be carried by these things. So I can get 8 on every X. I can get 15 on every Y. And I can get 22 on every Z. So that will take care of my portable TVs. All right, so then I've got my remote. All right, so 3 X's, so vans can carry 3 of those. Small trucks are 10. And large trucks are 20. And I have to have a total of how many of those guys? 85. And then finally, the other TVs, I have 2 on the vans. I have 6 on the smalls. And I have 5 on the bigs. And that has to be a total of 35. So there's your system of equations, and then solve it any way you want. So type it in on your calculator, you do it by hand, which I wouldn't recommend. You're having ones, so that would be really messy to do by hand. I just type it in with the calculator to do the work. Okay? All right, what else? Bless you. Let's see, what else do we have? Mr. Drury?
Can you do 5 on 7-1?
5 on the 7-1 homework. 5 on 7-1. We're going to Okay, so you got to remember that distance equals rate times time. And if we are going up, what does going upstream mean against the current? What does that mean? Does that speed you up, slow you down, what, Ben? Exactly. So if you're trying to go 10 miles an hour, but the current is pushing back at you 3 miles an hour, you're only going to end up going 7 miles an hour. Does that make sense to you? So you're positive, but the current's negative if it's going against you. So we know our distance is 1 mile. I have no idea what the rate of the boat or the current are, so I'm going to call them R and C. So upstream, if I'm rowing against the current, that would be my speed. If I let R be my row speed, am I rowing? Yeah, my row speed, and C be the current speed, then this is my rate. And it takes me 24 minutes to do that. So rate times time is distance. Now, what if I'm going downstream? What's happening if I'm going downstream? Then it's pushing me, so I'm going the same distance, so the same mile, but now my speed is R plus C. I'm going faster now, pushing me along, and that's 13 minutes. So what have I got here? A system of equations? So if I distribute, I have 24R minus 24C equals 1, and 13R plus 13C equals 1. All right, so you can solve this. Does it say how to solve it? It says algebraically. So that means we got to do it with substitution, elimination, Kramer's rule, whatever you want to do. So we got some yucky arithmetic in here on my calculator. I don't want to substitute. I really don't want to eliminate either, but I'm going to. So maybe I'll multiply this one by 13 and this one by 24, and that'll get rid of my C's, Ben?
Yeah.
Got it? Okay. So I'm not going to go through. We know how to do that arithmetic. So we go through and do it. When I did it, my X, what did I use different variables. My R turned out to be 37 over 624. And gotta be careful, make sure, because I did some unit stuff too. And then my C turned out to be 11 over 624. All right, so if I type that in on my calculator, just so we have a number that we can talk about, 37 divided by 624, that's like 0.06. So I am rowing at 0.06. Now, what's the unit on that? That's a speed. That's the speed I'm rowing. What is that? What would be the unit on that?
Would it be
What was this? What was this
miles
point?
a minute?
Miles per minute. So I'm going 0.06 miles per minute. So normally when we give speeds, we don't do miles per minute. What would be my miles per hour? What would I do to get miles per hour?
You just multiply by 60.
Exactly. And do the same thing with this one. And that would be how fast you were rowing and how fast the current was moving.
Do we need it in miles per hour, or would it be fine if we left it?
I mean, I didn't stipulate that. Common sense would be, I mean, usually when we talk about going in our boat, it's miles per hour, but, okay? All right, who else found something? Homework or review sheet, Jennifer?
The review number 14.
Review number 14. Now, this is exactly the same as the very first problem I did. The very first problem Bronson asked about was write the equation of the cubic function. So we started with the cubic function. This is a parabola, which is ax squared plus bx plus c. We know that parabolas are quadratics, and so I'm writing the equation of the quadratic function. So Jennifer, I'm going to do exactly the same thing. I'm not going to finish this problem because it's exactly the same, smaller than Bronson's, but the idea is take each point, so 2 comma 6, put 6 in for y and 2 in for x, and there's the first equation for the first point. And then put 31 in for y and 4 in for x, and then 4 in for y and negative 2 in for x. And there's your system of equations, solve it any way you want. Okay, that's like,
Would you use calculator or not?
what?
Would you use calculator?
This one would probably be a calculator problem. All of the big systems we've done on our calculator, except the ones that specifically say use Gaussian elimination. Okay, now that we got everybody back, I want to, I think we, no, never mind. Okay, all right, I'm gonna hand out some chapter 9 stuff, and if you don't come up with some other questions, we are moving on. So here is the homework for chapter 9. And I'll hand out the notes. There's homework. We're getting close here. I'm not sure how many more packets I'm gonna have for you. All right, everybody sure gotten 2 things? We good? All right. Anything else, Robert?
You 11-0.
Are you on the review sheet?
Yeah, we do.
We're gonna rotate matrix through 120 degrees. All right, Robert, what's the rotation matrix?
Sine, cosine.
No. I mean, it's got sines and cosines in it, but no, that's not it. Okay, so let's talk about this. I'm gonna do this problem, all right? But this makes me mad because if you study, that's one thing you're just gonna memorize. You just gotta know that. And if you don't know it, where should you be looking right now? In your notes. But instead you're sitting there asking me to do the problem again, and I'll do it, but I'm not doing it for you on Thursday. You have got to do this work, people. My gosh. The rotation matrix, cosine, what's my angle? 120. So cosine 120, sine 120, negative sine 120, cosine 120. That's the rotation matrix. No partial credit. You miss it, I'm not even looking at your thing. That's memorized, and not 120, but that format is memorized. Okay, now I'm gonna rotate that. I'm gonna apply that matrix to C, which is 2, 0, 3, negative 4. Now, this could be a no calculator problem because the angle happens to be 120, and we know 120, right? You can find the cosine and sine of 120. So you could actually stick fractions, like root 3 over 2 and 1/2, in here. On the test, it isn't 120, it's some other random angle. So this is gonna be a calculator problem. But I am going to ask you not to round off. So you are simply going to do matrix multiplication. This is a 2 by 2, this is a 2 by 2, so they're multipliable. It's gonna give me another 2 by 2. And to get this guy right here, I multiply this times this. So I take cosine 120 times 2 and negative sine 120 times 3, add them together, and that's what goes there. So 2 cosine 120, oops, better make sure I'm in degrees, I am. Minus 3 sine 120. I got negative 3.60 basically. And then I'll take this row times this column, so 0 times cosine, and negative 4 times negative sine. So 3.36. And then, now I'm moving down here, so 2 times sine 120 plus 3 cosine 120, 0.23. And finally 0 times sine and negative 4 cosine. Now, we've talked about, and because I rounded these off, there is round off. Don't get me wrong, there is round off in my final answer. But I didn't round off these things. We've talked about the fact that when you rotate something, you don't change its essential features. So like if we were doing a triangle, it would stay the same size, just reposition. So real quick, what is the determinant of this matrix? The original, we call it the pre-image. What is the determinant of this matrix? Negative 8. Let's find the determinant of this one. So multiply those, and subtract. And remember, rotation should not change any of the essential features. Did you get negative 7.9958? Yeah. So rotating it didn't change its determinant. It gave it all new numbers. Those are all new numbers in these, but it kept all the features the same of the matrix. Okay? By the way, that can be a check for you if you do any transformation. And remember, we not only did rotations, but we did reflections also. Any kind of transformation like that, you can check. Just make sure that you haven't changed the determinant, or you haven't changed the area, or you haven't changed whatever it is your deal. All right? Who else who actually tried a problem, tried it, and couldn't get it? David?
I just have a question. Will the reflection matrices be on the test? Will you give them to us?
No. And they're easy to figure out. Remember, if I said to you, I want to reflect this point across the y-axis. Remember, the identity is this. This is the beginning of everything. Even this, it's the beginning of that. By the way, the determinant of the rotation matrix is cosine squared minus negative sine squared, which is cosine squared plus sine squared, which is 1. That's the determinant of this. It's the determinant of all of the transformations. So anyhow, that's where we start. If you want to reflect something across the y-axis, what are you changing? The x. Changed it. There it is. X is changed. Remember, these are I and j. I is horizontal, 1, 0, j is 0, 1, y is 0, 1. So you are, if you're changing x, you're going to change this. If you're changing y, you're going to change that. If you are interchanging them, you know, making y and x, then you just write y first and then x. So you can figure those out. Don't waste time memorizing them, just, you can figure them out. This is your x and this is your y. What are you doing? What are you doing to x and y when you make whatever change it is you're making? Yeah. So all the reflections will be flips of some kind. So you'll just be putting negatives in, or you'll be flip-flopping the x and y. Okay. And we can apply these. This problem, we applied the transformation or the rotation to a matrix. We could have done it to a vector, because isn't that still multipliable? Yeah. So you don't have, it won't necessarily always be a matrix that you're applying it to. You could apply it to a triangle. So you could have, 3 points here. And as long as these 2 dimensions stay the same, you can do it. All right, who else tried a problem? Tyler?
Did number 1 on the quiz? The one you just did? This one.
All right, we've already done a Gaussian elimination problem. So your issue is probably arithmetic, if you followed what we did before. So I got 1, 2, negative 3, negative 13. I got 4, 7, 1, negative 35, 1, negative 3, negative 1, 9. That's what I got. All right, so just like before, I need to get zeros here and here. So I guess I'll multiply the top row by negative 4. 9 on my arithmetic, please. So that gives me a 0 and a negative 1 and a 13 and a 17. Does that look all right? Now I need to get, this is going to be easy. I need to get a 0 here, so I'll just multiply the top row by negative 1. And I get 0, negative 5, 2, and 22. So now I need a 0 here. And I'm going to go ahead and just multiply 3 by negative, so that's a 1, because that's supposed to be a positive 1, not a negative 1. So now I'm going to go ahead and multiply this by negative 5, and that will take care of this for me. 0, 0, negative 63, and life doesn't get any better than that, right? So technically, I should write one more matrix because it says Gaussian elimination, and that means the matrix has to be in row echelon form. Row echelon form. But clearly, this is going to give me the answer. What does that say about z? 1. And so y minus 13 times 1 equals negative 17. So it looks like y is negative 4. And then x plus 2y minus 3z equals negative 13. So x minus 8 minus 3 equals 13. Oh, wait a minute.
I think it's negative 13.
Negative 13. So that comes out to be negative 2. So that's my answer. Ben?
For the test, will you take points off, specifically right at that matrix? Say we just left it at the negative 63, negative 60, will we get points off for that?
I'm gonna ask that, we got a whole lot, yes, I am. Do it. Just do it.
Okay.
Okay, one more question, that's it, because we're kind of, I think, trying to stall here a little bit. So one more question that you have studied for. Tommy?
Can you number 2 on the quiz?
I don't know what quiz he had, 9 different quizzes, so I don't know which quiz he had. Did you put it in
It's
here?
up here. No, I put it there.
Where is it?
It's right here.
Oh, Lordy. All right, so we're finding the area of a triangle, and I did not give him a calculator. So, doing it with the law of cosines and 1/2 side sine and all that probably isn't a good idea if we don't have a calculator. So how can we find the area of this triangle? We're gonna use a determinant, but what goes in the determinant? Then two vectors, right? So I'll just use MP and MN. But it doesn't make any difference. You can use whatever vectors you want. You can do PN, PM, you can do NM, NP, wherever you want to start, whatever angle, vertex you want to start with, make those two vectors. So if I go from M to P, from -2 to 0 is 2, and from 1 to -3 is -4. And then if I go from M to N, -2 to 1 is 3, and 1 to 5 is 4. So then I'll take those numbers, make a determinant out of them, and evaluate that. So that would be 8 minus -12, which is 20. So the area of the triangle would be 10, half of 20. Remember, if that turns out negative, you just ignore the negative and divide it by 2, so the area is 10. All right, okay, test next time. Be ready. Let's get our notes out and start talking about our last chapter. I think I'll have a full chapter anyway. All right, so it started off with stuff to know. these things, for most of you, these are gonna be so obvious, but I wanna give you time. If you're not comfortable with the deck of cards, get comfortable with the deck of cards. Now, we're not going to be talking about all kinds of different games and rules and all that. No, 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 no. Physically, what does a deck of cards look like? How many cards are in a standard deck? 52. The number of cards in each suit. So you gotta know what we mean by suits. Diamonds, hearts, spades, clubs, right? There's 4 of them. So if there's 52 cards altogether, then there are 13 in each suit, right? You need to know this. This is basic probability. If you don't, it's okay. But either buy yourself a deck of cards, get online, ask a friend, but somehow you gotta know these basic things. How many faces on a cubical die? Okay, I know it seems ridiculous, but yes, you need to know there are 6 faces on the die. The number of possible totals when 2 dice are rolled.
6 factorial.
I heard 6 factorial and I heard 11. Okay, do I hear anything else? I want you to think about this for a second. When you roll 2, it says the number of possible totals. So what's the smallest total you can get when you roll 2 die? The smallest you can get is 2. What's the biggest you can get? 12. Can you get everything in between? So can you get 3 and 4 and 9 and all that in between? Yes. So how many possible totals are there when you roll 2 die? 2 dice. 11. Right? 2 to 12. 2 to 12, inclusive. Number of vertices of a decagon. 10. Number of musicians in a string quartet. Number of players on a soccer team. 11. When they say that, they mean that play at one time, not like including the bench and all that play at one time. The number of prime numbers between 1 and 10 inclusive. So you gotta know what prime numbers are.
4.
Alright, so 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so which ones are prime? Let's circle them. 1, 2, 3, 5, 7. What?
One's not prime.
Yeah, it's one of those picky little math things, but 1 is considered neither prime nor composite, so technically 1 is not a prime number. And that's just sort of one of those picky little math situations. So 2, 3, 5, and 7 are the prime numbers, okay? Oh, obviously they're on the The number of squares on a chessboard, 64. Our chess expert knows that one, good job. Number of cards in a contract bridge hand. Okay, I am never giving you a contract bridge problem, so you can cross that one off. We're not, I'm promising you, we're not doing any weird things. I will tell you in the problem, if it's a 5-card hand, if it's a 4-card hand, if it's a 13-card hand, I will tell you that in the problem.
How many musicians were in the string quartet?
Quartet.
I didn't know that.
Oh, David. All right. How many ways, now we're ready to start in. How many ways can 3 distinguishable objects be arranged? Now that word distinguishable is important. It means they're different. It means like having Max, Tyler, and Bronson. They are very different from each other. They are distinguishable. As opposed to 3 pennies that I get brand new from the mint. and they're all bright, shiny copper, and they all have the same numbers on them. Those are called indistinguishable objects, okay? But I got 3 different people. How many ways can I arrange them in a row? It doesn't always say that, but in a row. How many ways can they be arranged in a row? What do you think, Ben?
6.
How'd you get 6?
Because each one, I don't know how to explain it, but like you can only put a certain order, like you can only put the one object first with 2 different combinations.
Okay, so what he's saying is very good then. What he's saying is, here are my 3 objects or people. I'm gonna put somebody first in the line. How many choices do I have to put here? 3. I'm only gonna put one guy there, but I have 3 choices, right? So I can put him, or him, there. So I have 3 choices for spot 1. How many choices do I have for spot 2 then? Just 2, and then finally there's only one guy left, right? I have 3 choices, and I have 2 choices, and I have 1 choice. We will learn as we go through this that if you are doing this and this, that's a multiplication. That's a multiplication. So 3 and 2 and 1 choices gives me a total of 6 choices, 6 ways to do it. Very good. Anybody know what 3 times 2 times 1 is called? Somebody said it, yeah, earlier. It's 3 factorial. So in general, 3 things, I'm talking about different things, 3 different things arranged in a row is going to be 3 factorial. What if I had 4 people? 4 factorial, wouldn't it be 4, 3, 2, 1 then? So n things in a row is n factorial. N things in a row is n factorial. Now, there'll be some modifications of that as we complicate the problem, but in general, that's what we've got. All right, we're gonna do a few more, then we'll be done for the day. A license plate consists of 3 letters, so letter, 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 followed by 3 digits, number, number, number. Find the number of plates possible if there are no restrictions. If there are no restrictions. Now, what that means is you're allowed to put whatever letters you want and whatever digits you want. There's no rules to this day. So how many choices do we have for this first line? How many letters are there in our alphabet? That may be another stuff to know thing. How many letters? 26. Now, no restrictions. So I've got 26 here and 26 here. Now, if you look at the next problem, it says nothing can be repeated. Okay, well that's a restriction, and that's going to change these numbers. But right now, we can do whatever we want. All right, how many digits? 10, 10, 10. Now, obviously, that's not a factorial. You'll have to type that in on your calculator. It's going to be a big number, but that's how many license plates you could build if you were allowed to use whatever you wanted. So 17576. So it looks like 17,576,000. Okay? Now, same license plate, but nothing can repeat. So what will that change if you're not allowed to repeat? Bronson?
So it's going to start with 26, and then whatever you chose is going to be eliminated. It's going to be 25, 24, and then it's going to be 10, 9, and 8.
Perfect. And again, those all get multiplied together because you're picking a letter and a letter and a letter and a number and so on. So it's still a bunch. But less, it makes sense, there'd be less, right? last one we're gonna do today. I'm gonna make these license plates. There has to be at least one digit, and repetitions are allowed. Okay, so I'm changing the way my license plates look. I have to have 3 letters, but then I have to have at least one digit, which means I could have 1 digit, or I could have 2 digits, or I could have 3 digits. Now this last one, it says repetitions are allowed, so I think we've already done this one, haven't we? Haven't we already figured out this number? That one was, oh crap, I erased it. I think I can still see it here. Was it 17,576,000?
Yeah.
Okay. Now, what if you're only using 2 digits? Well, if everything's allowed, wouldn't it be 26, 26, 26, and then 10, 10? It says I can have repetition, so I guess that's okay. All right, so that will just be 1,757,600. And then if you're only using 1 digit, so your license plate is like LKF2, only 1 digit, then that would be 26, 26, 26, 10, which would be, I think that, if I write it right. Now what? I need an answer. Are you okay with the setup? Okay. How am I gonna get an answer now? What am I gonna do with those 3 numbers that I have? What am I gonna do with those? Robert?
Add.
Yes. Why do you think we would add them?
There's like 3 separate kind of possibilities, so like just add.
And we're looking for the total number of possibilities that we have. Here's the distinction, guys, because these are all multiplied. You're picking a letter and a letter and a letter and a number, so that is all multiplied. But our license plates can have 1 digit, or 2 digits, or 3 digits, and or always means adding up. So the answer is going to be the sum of those for exactly the reason Robert said. We have these different situations and we want the total. And I got 19,509,360. Did you? This stuff that we're doing here, obviously that's not probability. We're heading toward that. This chapter, the first part of the chapter is about combinatorics, what's called combinatorics. And that includes probability. But what we're doing right now is actually called the counting principle, the fundamental counting principle. If you have this many choices for the first letter and this many choices for the second letter, then you multiply them together. That's called the fundamental counting principle. Okay, I'm done blabbering. You've got, I don't know, however much time